So I asked the AI to draw a cartoon of an AI on the radio. So that's what we got. So that one is Nano Banana, part of Gemini, which is Google.
Using that to sharpen some less than ideal photographs.
Yeah, Nano Banana is great for all kinds of image processing, like sharpening photographs and removing backgrounds and. Yeah, this was the latest. Yeah, this was just days ago. But I thought it was
a future FT8 station.
yeah, and you notice it has a picture of
You're
him
still sleeping
over here. Yeah, and he's got a little waterfall going here. Yeah, it's kind of. I love the stuff in the background too. ARL, yeah. Anyway, I guess that's a very, very large postcard. I don't know. There's a little QSL cards down there.
Great.
And you notice he's using CW, even though there's FT8 showing back here. So I guess it's an AI though. It's probably doing all of them all at the same time, right? Yeah. Anyway, so before I dive into this, yeah,
Analog meter.
he's got it all going on all at the same time. Yeah. So yeah, here's another one. I love this guy's hat. It's very nice, and I love ohms. It's the T-shirt. Anyway, I'm not sure why we have random vacuum tubes on the floor, but anyway, so I'm going to go through a few things. I'm going to give you a brief history of AI, just because it's fascinating to me. 50 years it's taken us to get from where it started to today. And there were a lot of fits and starts in there, winters as they call them, AI winters. Then we'll jump into generative AI. Of course, that's the latest and greatest hot thing. And as part of that, agentic AI, which is the latest, hottest thing. I'm going to coach you a little bit on prompting. Prompting is a way that you get an AI to do what you want it to do. And if you don't master that, you're going to be very frustrated. So we'll talk about that. Then I'll give you some examples of AI in amateur radio and a little bit of a demo if we have time left over. But before I start, I thought I would give you an example of what I've done recently, just to kind of give you and get an idea of what you can do with it and get your creative juices flowing a little bit. So I had the idea that I wanted to create a field portable 2-meter Moxon antenna. Now I created one of these myself by hand a few years ago, and it works pretty well. But I was really, thought it would be kind of cool to have AI try to create the same thing. So let me show you what I started with. And this is an example of, let me go back to the top here. All right, so this is kind of what you might call a prompt. So this is what I'm telling the AI. You're an expert radio engineer with deep experience in VHF, UHF, HF antenna design, field portable operation, and 3D printed mechanical hardware for amateur radio use. I just bought a new 3D printer, so I'm all about printing stuff too. And so when I said design a complete field portable Moxon antenna project with the following specifications. So I first started with those first two stanzas, and then it dawned on me that I could ask the AI to tell me what it wanted to know, right? And so it actually went through and asked me a few questions and generated the rest of this prompt. So it came up with this: electrical requirements, 14652, the calling frequency on VHF. I want to be able to switch polarization, just for, if you want to run SSB or FM, it's nice to be able to do that. That's the application, simplex FM and SSB. The feed point should be a 50 ohm BNC. Mechanical requirements, I want to use aluminum tubing because I did that before. It's easy to bend. It's relatively inexpensive because it's a small antenna. I want to be able to fit inside of a backpack. I want to be able to set it up in under 2 minutes. I think that might be a little generous because I don't know if you're going to be able to do this in 2 minutes. But anyway, but with no tools, that's key. Weather rating, be able to use it in the wind and the rain. And it's okay to use some PVC tubing for the support, which you could also print, by the way, on a printer. But anyway, so then I told it what kind of printer I have, down to the model, what kind of material. PETG is a material that's UV resistant and it's fairly strong. And then the type of nozzle that a printer has, and the design priority was ease of field assembly and minimal part count because I wanted to be able to put it together and pretty quickly. So then the deliverables, and again, with an AI, you don't have to tell it all this, but the more you tell it, the better your chances of success. Right? So, we gave it all this kind of stuff. Use the antenna dimensions, use metric. Give me a clearly labeled table. And again, it created this list of requirements. I didn't do all this, right? I just asked it to create it.
So did it actually quiz you this? I mean, is
Yeah.
it listed? Oh.
Yeah, one of the things you can do with AIs is you can say something like, here's what I want to do, interview me and ask me the questions that you need to know in order to do this, and it will do it.
Yeah, sometimes it gives you a prompt back, but yeah.
Yeah.
What are those first principles?
Good question. I don't know what that means. I think it might be a radio engineering term. I don't know, Jerry, do you know what that means? Aren't you in that business?
As
Yeah.
opposed to the second principle?
Right. Yeah. I don't know. I'll have to ask the AI. I should have asked the AI what it meant by that. But anyway. All right. So here's what came out. Switch here. So first of all, it created this nifty build guide. Make it bigger here. And for some reason, it's using British spelling. I don't know why. But yeah, so we have aluminium. But regardless, so it basically summarized everything that I asked it to do. Here's the actual rectangle that it came up with. It calculated all the electrical characteristics, how much gain you're going to get. The feed point, all that kind of stuff. The switching, the configuration. Here's all the dimensions for the antenna in millimeters and centimeters. This is what the complete assembled footprint will be. Now, this is one where, and I'll talk about this in a second, I'm like 4 feet 5 inches. That's a big antenna, especially for field use, right? Now, it's great if you have a tripod or whatever, but if you get in the wind or whatever, 4 feet, you're going to have to guide that thing or it's going to be all over the place. I've seen that happen with Yagis in the field, like on top of Blue Sky / Mount Evans, where somebody was using a portable Yagi, all the elements kept coming out of it because the wind was just literally blowing them out of the antenna. So anyway, so that was the first thing I spotted. It was like, yeah, that's not quite optimal yet. But anyway, came up with a cut list, tells you exactly how to cut it. I mean, everything that you might need. Bill of materials. And again, this came from literally, a couple sentences that I gave it.
Which AI was this?
This was Claude.
Oh.
Yeah, I use Claude for almost everything. We'll get into that in a little bit here. And then it created the 3D printer files. And this STL files are literally what you can put into the 3D printer software. It's called a slicer and actually produce the parts. This is what really blew me away, is the fact that I didn't even ask it to do that, right? Well, actually, it asked me if I wanted to 3D print those, right? And it came up with the actual files. All right, but the big problem was it was too big. And so the next thing I did is I revised my prompt slightly. Oops, make it bigger here. Zoom in. Whoops, a little too much. There we go. Yeah, so this is what I told it. This is actually the conversation I had with Claude. So I said, it's very wide and narrow, would be pretty long for a backpack, yada, yada, yada. And so then Claude came back and said, yes, basically, you're correct. The standard formula is that, and it even told me which Moxon calculator that it used. And so then it gave me some options.
It gave credit to where it got the calculator.
Yeah, absolutely. Yeah, I've noticed that happening more and more lately because it's called grounding, where the AIs have been accused, and rightly so, of hallucinating things, right? And so it's gotten much better. These things have gotten much better saying, yeah, here's where we got this from, right? But anyway, yeah, so then it came up with a trade-off antenna with the variant, it's much smaller. And it just basically said, yeah, you're going to lose 0.3 to 0.5 dB of gain, so not a big deal. And you'll have a much more packable radio. And then it did recommend that you run it through the NEC2 modeling, but other than that, yeah, then it just ended up by saying, you want to work up those calculations into a revised design? And I said, yes. And about 2 minutes later, I had the revised antenna.
Where original design?
Yeah, the question was it aware of the original design? Yeah, this was all part of one session. And I'll talk about that because one of the things you have to realize about AI is there's this thing called a context window. And the context window is like a memory, right? And so the newer the AI model that's being used, the bigger the context window, therefore the more memory it has. So we're getting to the point now, like if you're using Claude consistently, like using the app or whatever, it will remember from session to session, but it does have its limits where it will forget after a while. And you don't really know where that point's going to be because it's always changing. But within a session, yeah, it's they call this vibing with the AI. Vibe coding is one term. We're actually using it to write programs. This is more of a vibe design session. But yeah, you're literally just conversing with it and saying, yeah, that previous one was fine, but let's tweak it, and then it comes up with a revision. It's literally like working with an engineer coworker.
So how much time for the original design and then the modification did you spend, like half an hour or something like that?
Maybe an hour tops. Yeah, probably not even that. It took it about 5 minutes to come up with the original design. And then, actually it took me more time to think about,
Yeah,
the
exactly.
dimensions and stuff and then come back to it, right? Yeah, and then I could show you an example of the file that it came up with. So there's design 2. So here's all the these STLs, if you can see that, are the things. And I actually had it generate an image of the final antenna. Which I thought was pretty wild.
Have you tried any of its STL box?
I have not. I just got this printer on Monday, and so I've been busy printing other stuff to start with. But yeah, this is definitely on my list. Because the problem I had with the one that I designed, I actually 3D printed the parts and manually kind of created them myself, but they're not very sturdy and require a screwdriver. So, when I had AI do it, I'm like, yeah, this is kind of where I screwed up. So, make it so I don't need tools and, all that kind of stuff. Yeah, quite. Yeah. Question was, did I have a previous printer? Yeah, I had a 2019, still have it actually, a Creality 3D printer that drove me absolutely crazy because being a first generation printer, it required a lot of fine tuning and coaxing, and you had to manually level the print bed, and the nozzle was always clogging, and it just drove me crazy. And this new one, I've yet to have a single print that just didn't work. Just press the button and it just prints. So
What's your new printer?
new printer's the Bamboo P2S, which is, what's that?
Cost.
The new one was $800. And that's their top of the line prosumer version. When you go beyond that, the next one up is 1500. So yeah, I wasn't going that far, but yeah, the $800 model has 4 spools of filament that you can feed into it at the same time, so you can change colors on the fly. It's fast. It's probably 10 times faster than my last printer. Yeah, it's really a joy to use. Actually, if you want to see it, I'm showing people here before. I'm printing something as we speak. I can come here to the app and hit the video button. And in a second, there it is, printing away. It comes with a built-in camera, and the app allows you to monitor it remotely if I want to pause it or stop it. It also has AI built into it, so if the print goes south, it'll shut everything down, before creating a big mess. So yeah, pretty impressive. I'm printing a new filament spool for the printer. That's what happens when you buy a 3D printer. You'll find that the first month, you're just printing a lot of stuff for the printer to improve it. Like a shelf to put underneath it, and stuff like that. So anyway, yeah, pretty cool. All right. Meanwhile, back to the ranch here. So yeah, I'm going to definitely build that antenna, and I will let you guys know how it works. And close some of this stuff down.
Can we actually see pictures of the parts that it wants you to print?
Yeah, I could open one of these. Let's see. Let's look at the handle. Where's the handle? There we go. First one on there. Yeah, I just double click on it. It opens it up in the Bamboo software. And I'll make it a little bigger, zoom in. And you can, now this is typical of what will happen with, when you design your own parts and you pull it into their software. This is probably the worst way to print something because it's got the little narrow part at the bottom, so it's going to tip over. So what you could do is you could just rotate it, so that it's flat, and then just hit the print button and off you go. But yeah, you can see all the 3 dimensions, and I've yet to figure, I haven't figured out how to rotate it yet, but I'm sure it's pretty obvious. Anyway, all right. Switch back to PowerPoint here. Okay, cool. All right, let's talk about the history of AI real quick here. So in 1950, believe it or not, they were already thinking about artificial intelligence. And Alan Turing, who is a very famous computer scientist of the day, came up with what he called the Turing test, which is a series of questions that you could ask a machine and that would test to see if it's actually thinking. And today we're calling that AGI, artificial general intelligence. And we have not achieved AGI yet, but depending on who you talk to, they think we're not too far off, within a year or two. And basically that means that a machine would have, kind of like in the movies, right, where it's thinking and has a personality. And I mean, some of the AIs today actually do have a personality, but it's basically where it would have a conscience and an actual, like a human-like brain. Now we're getting. I don't think so.
Came later.
Yeah, it came later, but this is part of his just very early thinking on how you test a machine to see if it could actually think. So early AI was what they call it symbolic and rule based. So basically if then else type of stuff. And I was involved in the 80s. I was working for a robotics company, and we had a little personal robot, and we wanted to be able to navigate around the room and memorize the room. And that was an example of very early AI where it was just learning from whether, like if it hit a wall, that would remember, okay, that wasn't good. And so then it would remember that, and the next time when it got to the wall, it would turn, right? So that was the kind of your basic machine learning, as they call it, or ML. But yeah, every one of the things that the AI knew the reason it knew it is because somebody programmed it into it, right? So, like if the frequency is less than 30 megahertz, then it's HF. So, could do things, but it was very brittle because, it was kind of a static type of a program. 1956, Dartmouth Conference coined the term artificial intelligence. Who has played around with ELIZA in the past? Nobody? Wow. Okay. ELIZA came out in 1965. You guys are way behind here if you haven't played with ELIZA. ELIZA was, it was kind of fun. It was an application, and you could talk to it. You could type in things. It would say something like, "How are you feeling today?" And you could say, "Oh, well, I'm feeling good." And it would come back and say, "Well, that's great." And so it was kind of a conversational thing, but it was all pretty much canned. It wasn't reasoning. It was just all kind of, coming up with responses based on what you were typing in. But that was kind of one of the first chat bots, and MIT came up with that in 65. Then in 1970s, they started to come up with these expert systems, and these were deployed widely in manufacturing, aerospace, defense, all these types of things. And the idea there was that it was AI, but you could code it as a human derived rule and then apply it to things. So one of the first applications for that would have been things like pattern recognition, like on an assembly line, being able to recognize by the pattern of whatever that part is, right? And limits, yeah, you had to have a rule for every case, so you couldn't really, anticipate very complex situations. It didn't learn from the data. You'd had to tell it what it knew. And that led to the first AI winter. So basically, there was this huge amount of funding in the early 70s. But back then, if you think about the state of computing, we just barely had 4-bit processors. Memory was crazy expensive. Everything was really slow. We just didn't have the, the capacity to do anything more than that. So that led to an AI winter, as they called it, in the early 1980s. And what they meant by that was that they just stopped funding AI altogether because they just didn't think it was going to be realistic for a while. So that was in 1980s, overpromised, underdelivered, funding dried up, everything hit a wall. Then in 1986, they came up with a thing called backpropagation. And that was the beginning of a neural network. And if you don't know what a neural network is, that's what every AI that we're using today is based on. They literally took a blueprint of the human brain, which is a big, massive neurons, and they started to model it in software. And so that was the next huge breakthrough in 1986.
Rediscovered on there.
What?
So when was the previous,
What's that?
the back propagation rediscovered?
Oh, yeah. I have to look. I can't remember exactly what that means. I think it's a type of like a recursion that it uses in learning and training the neural networks. But yeah, I'm not sure when it was first discovered, probably in the early 80s.
Is that their products, on the phone and whatever, they actually have a neural chip.
Yeah, right.
Is that what we're talking about?
Yeah. Yeah, the new phones, my new MacBook that I just got, they actually have AI chips built into them, which are our neural chips. Question was, what languages were they programming in? Probably mostly Fortran, I would think. Definitely not COBOL, Pascal and C a little bit later in the 1980s. But yeah, I would imagine they probably started with Fortran. Yes, sir. Lisp, yeah, Lisp was an early AI language. I never really did much with it, but yeah, I've heard of it. All right, so the problem though was in the late 80s to 90s is the processing capabilities were still too expensive and or non-existent to really realize, the practicality of what had been invented. So interest faded again for a while till about 1997. You remember when the IBM, I think it was called Deep Blue, beat Kasparov at chess? Yeah, and then later on, it won Jeopardy. Yeah, so that's what really started to regenerate a lot of this interest. But it was still rules and brute force. It was not learning. It was something that you had to program. But we were getting to the point where, especially with like mainframe technologies, where the CPU capabilities were getting to the point where they could start to actually do some realistic processing. Then into the 2000s brought us into statistical machine learning. This is where it's the last generation of AI before we got to where we are today, where you started to see things like self-driving cars and automated warehouses and things like that. Pattern recognition, especially visual recognition, got much better. You could start to, it was really good at detecting patterns in all kinds of digital data. And so that's what started happening in the first part of the 2000s. Oh yeah, this is another big application. Spam filters and search rankings. Search engines were all built on machine learning. You're going to ask me that. So my notes have a lot of detail on all of this. So yeah. Yeah, that's the Bayesian algorithm, but yeah, we don't have a lot of time to talk about. The speaker notes in this deck have links to virtually every one of these things. So if you want to really learn what a random forest is, knock yourself out.
Classification algorithm based on Bayes' theorem.
What he said. Okay. Yeah, spam filtering definitely was a huge part of that. All right, so then things started to really accelerate. In 2012, there's a thing called AlexNet, and yeah, CNN won it. Interestingly enough, not sure how they pulled that one off, but and then artificial intelligence networks generative adversarial networks started to take place in 2014. That's where you started to see AIs that could generate images, and they were pretty bad to begin with, but they've obviously gotten a lot better. Where things really took off and caught fire was in 2017. Google wrote a paper called "Attention is All You Need," and it's an interesting read. It's out there, obviously you can just Google it. And that became the architecture between all the modern LLMs. And Google spun up a division called DeepMind. And DeepMind really generated the first large language model and pioneered a lot of this technology. And interestingly enough, at the time, Google didn't realize the potential of that. In fact, they kind of backburnered it. They almost sold the whole thing off.
Yeah, exactly.
Right. Yeah, they were going to sell it to Meta was bidding on it, which was Facebook at the time, and so on. And interestingly enough, a lot of the people that were in that team quit and started OpenAI. More on that in a second here. But yeah, there's a book that just came out called Building the Infinity Machine, literally just published. And it was by the lead guy that started DeepMind. And it talks through that whole period. It should be a very fascinating read. So really in the 2010s, what was going on was three things. Massive data sets. So data became cheap to store. And these massive data sets started to emerge, aka the internet. GPUs, which stands for graphical processing unit. Everybody knows what a CPU is. So a GPU, which is what NVIDIA pioneered, and everybody now knows NVIDIA as the number one chip maker for AI. But back in the day, they made video cards for gaming mostly and high-end applications. Well, they realized that these GPUs were ideally suited for the type of math that AI needs. And so now NVIDIA is like the most valuable company on the planet because of that. And they came up with this platform called CUDA, which is the foundation for running these GPUs. Improved training algorithms, neural nets that were too slow were now fast because of all this available data and available processing. And the interesting thing that was happening in amateur radio, starting to fold that in a little bit, was that right around that same time, we started seeing better hardware, SDRs, for example. SDRs were part of that whole revolution. Software-defined radio is what I meant there, and better software.
But the SDRs, the big SDRs have still not replaced their gate arrays with the graphics hardware. I don't think like Flex and
No, yeah, I think you're right.
and stuff like that, which sort of has surprised me. I don't know if it's a cost issue or.
Yeah, the question was the big SDRs like Flex haven't replaced their gate arrays with GPUs. I think it's probably because they don't need to.
It's such a defined set of
Right.
Maybe
Yeah.
so.
Yeah, and gate arrays are, like you said, are probably orders of magnitude cheaper than GPUs are. Yeah, and what you're probably going to start seeing too is a lot of that processing is going to be offloaded. It won't be done in the radio; it'll be done in the cloud somewhere. All right, let's get to the good stuff, generative AI. So how machines learn to create, not just classify. All right, so this is what really amazes me. If you think about, any kind of major, advancement, like the machine age, things like that, those types of things typically took decades, 20 or 30 years or more to take place. This revolution has happened. The first one, the roots of it were in 2018, but really, OpenAI launched in 2023. That's when it exploded. It's been 3 years, and we've made just incredible progress. So let me throw a couple things out here. So in 2018, GPT-1 was the very first model, and that was where OpenAI and Google proved that they could work for language, right? So that's where you started to see AIs that you could actually talk to and could actually respond to you in an interactive way. Then things like in 2019, these early GPTs were pretty slow, pretty limited. Because they didn't have a lot of data in them yet. They were kind of toys more than anything back then. And then the other thing that started to creep up was people were starting to get very concerned about safety, AI safety. In other words, what can this thing do? What it's going to be used for? So they started to think about maybe we should hold off on this until we can get at least a little bit of a handle on how we're going to, ensure safety on these. You start to see this term of parameters. So in 2020, GPT-3 had 175 billion parameters. A parameter, just think of a parameter as like a piece of memory, right, inside of the model. The bigger the model, the more the parameters. So 175 billion sounds like a lot, but it wasn't, right? At the time it was, and this is where people are starting to build apps without fine tuning for the first time. 2021, DALL-E and codecs. So that's where the text to image started to come into play. DALL-E was one of the very first image generators and still continues to this day.
That stands for.
I don't.
I remember seeing it all the time.
Yeah. And then codecs was a code generator. We'll talk more about that in a second here. The big one,
Yeah.
it's Wally's brother, Dolly, or sister maybe, I don't know. So in 2022, that was the big one where, it was November of 2022 and OpenAI launched ChatGPT. And that really caught the public's interest. 100 million users in 2 months. Incredible. And the fastest adopted tech product in history. Today I think they count the number of daily users in the billions. It's just mind-boggling. 2023 is really when GPT-4, which is an OpenAI model, came out, and that was the first one that was really, really usable by the public and had enough data behind it that it became useful. And the concept of open models. So a couple of terms. You'll hear the term frontier model. A frontier model is simply an AI model that is the latest and greatest. Okay, so whatever the latest GPT is, we're at 5.2 or 3, whatever it is right now, ChatGPT. Gemini 3.0 is the latest frontier model, and so on. Somebody's beeper going off?
It's 11 o'clock, hilarious.
I don't know where that's coming from. Oh, it's that clock back there. Somebody set the alarm for the clock. All right, well, I'll just keep going while somebody get a hammer and fix it. Yeah, so, and then also there are open source models now. So open source means it's a model that's publicly available that you don't have to pay for. Excuse me. Is it coming from that? Yeah. So the clock on the back of the wall is going crazy right now. Okay. So that kind of started the democratization of AI, right? Where, like, I just bought a new MacBook. I can actually run an AI model on my MacBook for free. So if you have enough, if you think about a laptop running an AI model, even a year ago, that was practically impossible. Right?
Raspberry Pi.
No Raspberry Pis, though.
So which chip?
Like the
do you
open
use
top?
for your Mac?
What's that?
Which process?
Oh, it's got the whatever.
Is it an M5?
It's an M5 Pro. Yeah, and it's got one of the things you'll see when you're buying new laptops nowadays, if you're buying a high-end one, is you've got the CPU, like the M5, and it also has GPUs in it, which they're now calling something else. I forget what it is. Neural processing chips, basically. So, yeah, so I can go to like one of the big markets out there, open source model markets called Hugging Face. And I can go to Hugging Face and I can download hundreds of free models. And if I have enough CPU and RAM and stuff, I can run it on my own machine. But Raspberry Pis, you can do certain things, but you can't run an actual model on it. And an open weight model just basically means it's a model that can be continuously learning. And it can be trained. And then the hottest thing now, I was just at a security conference last week, agentic AI is the big thing. And what that basically means, I've got a slide coming up on this, but basically it allows you to, if you think about it, the GPTs and the chatbots they would listen to you and they could reply, but it was all text-based or maybe an image that it's generating. Agents have agency, which means that they can take actions. So now we have AIs that are capable of going out and doing things for us. And that has just caused an explosion in applications and safety concerns and all kinds of other things, which I'll get into in a minute here. All right, so what is generative AI? So it produces new content content, text, images, code, audio, 3D models by learning patterns in existing data rather than following explicit rules. So when they started building these GPTs, or large language models, LLMs, they literally just turned it loose on the internet, right? So it just went out and everything it could find, it consumed, and it used it to build the model, right? So inside of this model, it's a giant neural network. So again, it's like our brain, right? And so it's learning all of this stuff, all of these images and music and text, all that whatever it could find that was publicly available, would wind up into these models. So you can imagine the size of these things, right? I mean, they're talking about these things are growing so fast that in the future, there might be a model that consumes an entire data center. I mean, that's how big these things are getting. But that's the big difference. Rather than having to tell it through rules or whatever, it actually goes out and just kind of independently consumes all this data and learns it. So, yeah.
So how is it making mistakes? So let's take these bad legal summaries
Yeah.
that they're putting that they're putting into things. Shouldn't it be comparing sources, and is it not doing that?
Yeah, so the question was, how are these things making mistakes or hallucinations, as they're being called? So what happens is, when they first built these models, they built them to be very goal-oriented, right? So it's almost like a dog, right, that just wants to please, right? And so, excuse me, if you ask it a question and it doesn't really know the answer, it could make one up, right? Excuse me. And that was a problem with the earlier models. And what they've done in the meantime is, first of all, they've learned how to code them to the point where, they base most of their results on actual data. And there's also a term called grounding, which is where you can connect it to known sources of truth and then force it to basically just use those sources when it generates a response. So like I haven't had a real hallucination come out of an AI in quite a while now.
You're
But
not a lawyer.
no, I'm not a lawyer, right? But that's probably part of the problem is the lack of grounding in whatever that model was using, to make sure that it's not making stuff up. Yeah, Larry.
Who vets the truthful sources?
Yeah, question was who vets the truthful sources? Well, that's a good question. I don't know. It's up to the people that are building the models. But they do have, like I know a bit more about the way Anthropic does things. Anthropic is they've been in the news a lot, so you guys have probably heard of them, but a couple months ago, nobody had heard of them.
Yeah.
That's Claude, yeah. And Anthropic was founded, there actually was a bunch of people that left OpenAI because they had concerns around the safety of the models that were being generated. And so they started Anthropic, and that was one of their core founding principles was safety. And so the thing is, like, you've got an entire team of people in these companies that are tasked with monitoring the safety of these things. So they have, whenever they are developing a new model, they have a series of tests, things that they run through it, and they monitor the output, to make sure that, it's doing what it's supposed to do. But at the end of the day, the other thing that's really tricky about these LLMs is that they're what's called non-deterministic. So in other words, you can ask, it's like a human. You can ask a human the same question twice, you won't get the same answer twice because we're inherently non-deterministic. Well, these are based on neural nets, which are based on humans. So guess what? The same thing can happen. So if it's not like testing code where you used to be able to just run this suite of tests, and you got to the end of it, and if it all came back the way you expected, then you could say, good, ship it. Well, with an LLM, that's really hard, right? Because it's very subjective as far as what's going to come out. So, the testing and the safety mechanisms have needed to get a lot better, and they are getting better, but they're still faulty sometimes. Okay, so there's kind of three different types of AI today that we can use and are being used in these models. One is just discriminative AI. So last month I talked about how I was able to use Claude to identify some digital signals off the air, right? So that's actually more classic machine learning, but that's also incorporated in these models, right? So it's been, it probably went through the ARL website and a bunch of ham radio websites, and it found these signal sources, and it went into its memory. And now when you feed it, it just says, yes, I can see that. This is what it is. So that's discriminative AI. Generative AI, that's where we're just basically asking it something through a prompt and it's creating new content. And it's typically language, but now it can be text, it could be a 3D model, it could be sound, music, video, all kinds of things. And that takes us to the multimodal AI, which is where I'm literally giving it a picture. And I've done this, by the way. I was going through a bunch of jewelry from my mom's estate, and I had no idea what it was, and I literally could give it a picture and from my phone to Claude, and it would go out and say, oh yes, I found this on eBay. It's 100% match. This is what it is. This is probably what it's worth. Incredible. You can even,
Chinese.
yeah, exactly. That's how I, bought my new Mac. No, just kidding. But it could actually, I took a picture of the back of some silver and actually could read the sterling stamp, without a magnifying glass to tell me that this was a sterling silver piece of jewelry. So,
Real nice photograph that I got years ago, and it turns out that it's a mountain in the Cascade Range, Washington State. And I put the photograph in there, told you the name of the range, the mountain size, the elevation, what topo map to go to walk it.
yeah.
Yeah.
So the example was giving it a photograph and having it identify exactly where it came from, generate a topo map so you can hike it if you want. Yeah, it's just mind blowing. Okay. So here's how these LLMs work. So the first thing they do is these models have to be trained. And training is arguably the most expensive part of creating these models because you literally have to consume trillions of tokens worth of text. Now, a token, by the way, that's a really common term that you're going to hear with these AIs. And token is basically a chunk of text. Typically, if you have to separate it down like 4 to 6 characters. Okay, so whenever it's ingesting whatever it is, it's converting all this into a token, which then goes into a database. It's called a vector database. So if you know what vectors are, a force and a direction. These databases are all built around vectors. So this data is broken into tokens. There you go, 3/4 of a word. So an antenna might be ant and enna, and that goes into the database. Then there's a transformer level. That's the T in GPT, general processing transformer. And that's where the model allows you to basically figure out how these tokens are all related to each other. And then what happens is when you're doing the actual processing, like when you're processing a prompt, it's going out and it's trying to figure out probabilistically what the next token is. That sometimes is called the next logical word. So like if you're asking it a question, it's going to take that question and say, okay, so what's the likely connection from that sentence to an answer is? So this is all very complex kind of probabilistic processing that's going on.
Like on my phone, I had a message the other day. As I was typing, it's guessing the next word or 2 or 3 words.
Yeah, kind of like predictive text on your phone, only on a much larger scale. Obviously, it's like doing that for the entire internet. What's that?
Similar, except much more complex.
Yep. Similar, but much more complex. And then the last step is fine tuning, and RLHF basically means human feedback. All right, so that's where humans are actually going to be sitting down and running tests and things to make sure that it's working properly and that kind of thing.
Is it possible that a human would be able to figure out if the thing was safe?
Figure out what?
If the thing was safe, instead of looking safe. I'm thinking specifically about the big tip with the government and about the autonomous weapon.
Yeah, so
Which to me has been thoroughly discussed in science fiction since.
right. Yeah. So Larry's question was, is it possible for a human to determine if it's safe? Well, there are certain suites of tests that they run automatically. There's several categories of things they look at, like bias is one, right? To detect if there's bias in, like any kind of bias, gender bias, racial bias, whatever. Also things like, not safe for work type of content. So there's all these classifications they go through. But then there's sort of a meta model, which to Larry's point, one of the things that got Anthropic in hot water with the government was their concern about how their AI was going to be used. So for example, Claude was used when they did their recent acquisition of the leader of Venezuela. Claude was used to help figure out where he was and all the logistics around that. Excuse me. So it's already being used in defense and war. And so, the founder, the CEO of Anthropic, basically wanted the government to guarantee that, excuse me, it was not going to be used for autonomous monitoring, of populations, especially in the U.S., as well as automated mass destruction, type of technologies. And that one remains to be seen. If there's a way, I don't know if there's a way that they can tell necessarily, because they're taking these models and they're using them in their own environment. So like Anthropic has no control over what the government's doing with it. So it's almost like the honor system, right? If they put it into the contract, they can put it in the verbiage into the contract, but it doesn't guarantee the government's going to follow it, right? Unless they, right, exactly. It's almost guaranteed that they won't. So anyway.
I was just gonna say though, that they say that the military can acquire data, like they can only analyze like 5 or 10% of the data they analyze.
Right.
And using AI is a tool that allows them to be much more able to look at all the data and understand what's going on. So that part of it seemed pretty fascinating.
Yeah, we're seeing applications for that in cybersecurity, because as you guys probably know, that's what I do for a living. And one of the classic problems with cybersecurity is almost an embarrassment of riches. There's so much data coming in, and so much of that is meaningless, right? But buried in this haystack are a couple of needles, right, which are the indicators that there's an attack going on. But now they're describing it more as like a field of haystacks, and you got to find a needle in a field of haystacks. And AI has started to actually make an impact on that, being able to very rapidly process this data, throw away the stuff that it knows is not significant, and very rapidly drill down to the, somebody described it as burning down the field of haystacks to find the needle. Right. And so, yeah, we're seeing that all over the place. And government would be a perfect place because they've got all this intelligence data coming in and be able to rapidly
Trying to watch
interpret that.
move, missiles around and stuff like that. They're
Yeah.
watching all this on a really large country,
Yeah.
trying to figure out where everything is. And it's like,
Yeah. Yeah. I mean, it's applicable to any big data problem, and the government is probably one of the biggest consumers of that kind of data. But yeah, I mean, one of the things that I track every year is I ask the folks that work in security how many alerts they get every day that they're unable to get to. And even as recent as last year in 2025, it was 45%. So 2 in 5, they don't have the capacity to get to all those. And so, buried in that 2 in 5 is probably some nasty stuff. And now, I'm hopefully in our 2026 survey, we do this survey every year. Hopefully it's going to start going down because of AI, but we'll see. All right, agentic. So as I mentioned, agentic AI allows a generative AI model to begin to take actions. And we've got some humorous stories. Dan, a second ago, mentioned OpenClaw, which we'll talk about, because how many of you guys heard about OpenClaw? It was in the news. Yeah, a few. Okay. It's pretty interesting. But anyway, getting ahead of myself a little bit. Yeah, so there's the chat bot. You're just asking a question, and you get a response, or you get an image or whatever. The agentic, I can say, like I showed you, design an antenna, model a case, draft a parts list. It's actually taking action. It's going out. It may be employing other tools, and maybe doing an internet search, and it's doing all that to generate whatever you're asking it to do. Another example of that would be, like in the security realm, they're using agentic AI. So if you've got a system that's processing all this data and it finds out that there's an attack underway, You could have a remediation agent that then tracks down the source, like it might be a user that let their password go or whatever. And if you can track it down to that level, you just turn that account off and boom, you've just stopped the attack, right? So this can all be done automated. So that's another example of what an agent can do. So examples of that, Claude Code and OpenAI's got an equivalent product called Codex. And those are code generators. And I talked about that last month. I generated the entire new website for the club using Claude Code in a matter of hours. That's really democratized the entire process of code generation and programming, which could conceivably put a lot of programmers out of work. But, you know, whatever, it is what it is. It's here. Pandora's box is open.
I was gonna say, never put the genie back on the
Nope.
box.
Claude CoWork is another one. I think Danny, were you using CoWork the other day? Yeah, he was telling me about this. CoWork is an agentic solution by Anthropic, part of Claude, that will integrate with you telling it and allowing it to do so into your computer. So for example, you can connect it to your Outlook, to your email, to your calendar, excuse me, to PowerPoint, Word, whatever, and have it do things for you. One example would be to have it, say, I'm in cybersecurity, so I could have it scan all of the websites of the news of the day and generate a summary for me first thing in the morning, kind of like having an assistant, right? And so I wake up and I open up and I've got an email from Claude and it says, here's the things you need to be paying attention to. I could also give it access to my calendar. So it could say, here's your schedule for the day. Oh, I've detected that there's a conflict. It literally can do this, that there's a conflict. You have two meetings scheduled at the same time. Which one do you want to do? And you want me to send a note to the other people telling you that you need to reschedule? I mean, stuff like that.
Google can say what, and it brings up a program or,
Say again.
Claude. So if you go to Claude, say I wanted to install it on my computer or whatever it is. So I just go to like Google, say, find Claude, and then have Claude, then we'll bring up how to put it in.
So yeah, so I think your question is how do you install it? Okay. Yeah, you just go to anthropic.com and there's a Claude app. And there's apps for your phone, your tablet, for Windows, for Mac, all of those.
Just use it in the web browser.
You can also use it in a web interface as well. You can sign up for a free account. And then if you start getting into things like Claude Code, you have to sign up for their Pro, which is $20 a month, $20 a month, which I exceed constantly. But I always joke that, Uncle Claude's telling me it's time to go to bed when I run out of tokens. But anyway, yeah, it's easy to install. And then the key is, though, if you're going to use the agentic side like CoWork and whatnot, you have to have the app because the app is resident on your computer and has access to the computer's resources, right? But if you want to just chat with it, yeah, you can just do it through the web and whatnot. So you're going to see a lot more of these little agents becoming available. And the only thing that's kind of scary, obviously, is you're giving this agent, which is part of a public, AI, access to some of your personal data. So again, safety and privacy become concerns, which is why I have not given it access to my calendar and stuff like that. But that's me.
If you have a paid account through your work, don't talk to the chatbot from work like it's your therapist.
Right.
Yeah, exactly.
Yeah. If you have an account from work, don't use the work chatbot as your personal therapist because your work can probably, use that data one way or another. And that brings up a great point, Dan, though, and that is that a lot of companies, like I work for S&P Global, right? The S&P 500 company, right? And so we're a large company. We own our own AI company called Kensho. And so we've got our own AIs. And so we've got versions of Claude, OpenAI, and so on, but they're all part of our internal network. So they're not out in the internet. And so we can use it for all of our work-related tasks. But at the same time, they warn us not to use the public AIs for anything that has any of our confidential information because that can become part of the training model. And you don't want that.
Running on your servers, or are you can they partition those off like a Genic or something?
Yeah.
and make it profit for your company. They must be able to do that.
Yeah, it's a little bit of both. So Mark's question was, is it running on our own servers? It's not running in our own data center per se, but it is running in our own virtual private cloud, which is hosted by Amazon AWS. And so we own that and no one else has access to it. So it's running in the cloud, but it's a private cloud, as they call it. And so we're hosting all of our own models and everything inside of our own environment. And
That's not allowing you to do bad stuff. Correct? Just like the whole government. You can't just now.
right.
I don't mean to get off the topic, but so let's talk about all the dark web people, right?
hmm
Can they build, buy, or somehow acquire their own AI?
Question was,
And then there's no limits.
are the criminals using AI? They are 100% absolutely doing that. And we're seeing it already. In fact, what you're seeing is these folks that have developed these attack techniques can now turn AI agents loose and they can run 100 of these at the same time, where it used to be they were doing 1 or 2 at a time. So the scale is going up and the speed of these attacks is going up, which is then turning into a blizzard of technologies on the defensive side. Organizations are rapidly figuring out that the only way they're going to combat this is through their own machine speed defenses. So AI is it's just a war all over again, one side versus the other, and it's going to be all AI powered by necessity. But yeah. And the other big thing that's happening on the criminal side is, the deep fakes that are being generated, the images and the sounds are getting better by the day, to the point where it's becoming indistinguishable. Yeah, Michael.
Character is a synthetic personality layer that goes onto large language model. And I input my voice for a ham radio operation.
Yeah.
And I realized that any of these models can acquire really just one sentence of our voice and impersonate us indistinguishable from our own personality.
Yeah, Michael's point is there's a thing called character AI, which can sit on top of the LLMs and can take a very tiny piece of voice from an individual and turn it into a virtually indistinguishable, copy of your voice. And I saw this happen.
And that's in his own voice.
They wouldn't recognize it.
Probably break it actually, but I saw this about 3 weeks ago, I think it was, at the Cisco AI Summit, where the guy was on stage and he literally had a conversation with a doppelganger of himself that was fully AI generated video and audio entirely from social media sources.
This brings me to the next thing that happened with character AI. They have a Baofeng 5R on there and you can use it. And I found another ham and it turns out it was a silent key with a valid call sign. And it was aware that it was a silent key.
Wow.
I had a full QSO with the silent key on the character AI. It was
Wow. So
strange.
Michael had for those of you on the other end, he had a full QSO with a silent key using that character AI. Yeah, that's creepy.
It was.
But yeah. Larry, I think you were first.
One of the programs listening to, one of the fellows there was made aware of his voice being moved. And since he's in the public sector, his voice is very important to him. And someone says, this is imitating you because I happen to know that you weren't there where this voice was going on. He said it did a perfect imitation of his voice inflection, his pauses, his and or stuff like this, and it was indistinguishable from him suing them, saying, "You are taking over my radio personality."
Yeah. Oh, there's all kinds of lawsuits going on right now. Like the New York Times is suing OpenAI, Perplexity, and I don't know who else, but for copyright infringement for things like that. And, that extends to people's voice and image and, like me, I'm all over social media and stuff. Anybody can pick up my voice from one of the webinars that I do and use it for anything.
Yeah,
right?
use one of the microphones just to play this.
Yeah.
Which one? This one?
Let me just stick it up right here.
Okay. So you've all heard my voice here. Here's the character AI model of my voice.
Sure, I'll conduct the chat as a traditional amateur radio operator for AF0SF. My call sign is AF0SF, and I'm ready to begin. Let's start with the standard exchange of information. Please state your call sign, power output, and antenna height.
Yeah. This sounds slightly robotic, but yeah. But yeah, it's definitely your voice. Yeah. So, and as stuff goes on, it's going to get more and more natural and harder to distinguish. So this being applied a lot for spam email, robocalling, all of that stuff is all using AI now. Yeah.
Coming out and especially with deepfakes, when they start getting so good, how are we gonna know what truth is?
Yeah, the question is how are we gonna know what the truth is? Yeah, it almost kind of brings us back to the Turing test, right? Where, like there's all these North Korean folks that are being employed by North American firms because they can convince them, that they're a legit remote worker and they're actually doing IT work. They're doing legitimate IT work, but that money's all going back into the North Korean government, right? And so, it's to the point where you really have to be able to get on a video with a person and ask them questions, that an AI wouldn't be able to answer.
I've seen this video this week that came out. They're asking the guy, please determine that you're not an AI deepfake by putting 3 fingers in front of your face. And then it's a white guy's voice, saying the white guy's face, saying it to the video. And he goes, "Oh, Ronnie, what do you need that for? We're legit." And he grabs this thing off the wall and it's got his degree, whatever on it. And he's looking straight at the camera. He never looks away to grab this thing. And he says, "We're legit." He's like, "Is that your diploma?" "Oh no, that's my director's." And he puts it back. And he's like, "Once you put 3 fingers in front of your face, put 3 fingers in front of your face." And he's like, "Oh, what, Ronnie, what do you need to do that for?" And he's like this, and he puts 2 fingers down here because he can't put 3 fingers up here. But if he does, the layer that they're running over the top of the guy in India who's actually talking and making the deep fake, it would disturb it. So he can't spin the chair around. He can't do 3 fingers in front of his face because it'll blur out the layer that they're putting on top of this thing.
It's like a kidnapper's
Yes.
life
Yeah.
photograph of a newspaper.
Yeah, proof of life kind of thing that you have to do. Yeah.
3 fingers in front of the face because there's no real camera.
Right. Yeah.
It's
So
on Zoom, and it was a Zoom call, and then the bot, whatever deepfake person found out the Zoom call.
Pretty neat.
Yeah.
yeah, back there.
Scary.
Why are you gonna tell?
Question is how you get to, well, it's evolving every day, right? So I don't know what the answer to that is, honestly.
This week's trick won't work next week.
Yeah.
I have my AI call you.
Yeah, my people call your people, right? Larry, did you have something?
There's gonna be a psychological mess, because they can take anybody, like we're talking about here, and you can
Yep.
put somebody on the computer, and it can look like that person, you can talk to that person,
Mm-hmm.
and people are gonna be doing that with their lost kids and their lost mom and dads, and
Yep.
I think there could be a psychological mess.
Yeah.
People using that in a unhealthy ways.
Right. Okay, Larry.
I'm thinking the danger is absolutely you hear about things that AI is able to do. And that in your mind, that transfers to say, oh, that I can trust AI for this. I'm thinking specifically, several medical breakthroughs have come through
Mhm.
where AI, for instance, can detect breast cancer with much greater accuracy than having a
Right.
mammography for the woman. But they did a test recently setting up an AI asking about information you would ask your doctor.
Mhm.
And they had script, so they said, well, I'm experiencing the following, this, that, and the other. And AI did horribly. And in some of them, they set up, it was a situation where any doctor would have said, you need to go to emergency right now. And AI came back and said, you need to take an aspirin.
Take 2 aspirins and call me in the morning. Yeah. Yeah.
People hear about the fantastic specific medical things that are being done.
Right.
And then they transfer that over to, well, it can figure out cancer in this person. It should be able to tell me whether my cold is serious.
Right. Yeah. So Larry's point was all around getting medical advice. This is true for car repairs or whatever. We over the past 15 years, people have been Google MDs, right? Oh, well, Google said, I have this. Like, well, did you actually talk to a real MD? And oftentimes it was wrong, and a lot of people probably died because they took the advice. And now AI is even worse, right? Because you don't know. And because one model is good at detecting cancer doesn't mean that the public model, has been trained on any of that same data or whatever. Yeah. So you always have to be very careful with any of that kind of information. Yeah, Michael.
This makes me think of the doctor who myself and Abraham Lincoln's quote, "He who represents himself as a fool for a client."
He who represents himself as a fool for a client. Yeah, that sounds about right. Okay, let's move on, or we're probably never going to get through all this, but great stuff. Real quick, let's just go through some prompting techniques. So again, I think partly too, kind of to your point, Larry, if you are going to use AI to diagnose a medical problem or design an antenna or whatever, it's garbage in, garbage out, right? So the less information you give it, the higher the probability that it's going to give you garbage back, right? So if you can, and I've seen this myself. So speaking of medical information, so I gave Claude a list of all the prescription medications that I take. And I said, first of all, tell me, are there any interactions? When should I take them? Should I take them with food or not? All these things I asked it, specifically all these questions, and it came back and it said, I don't see any interactions. You're on cholesterol medication, so don't eat grapefruit. That's kind of common knowledge. Good to know though. But actually, it did tell me, like, I take a thyroid pill. It said, take that first thing in the morning before you drink coffee, because coffee can dilute the absorption of it. I never knew that. I've been taking this for 26 years. I never knew that. Right. Synthroid, thyroid meds. Yeah.
I knew that about coffee.
Yeah. Yeah. There's kind of a little bit of debate there, but they say wait 15 minutes before you drink coffee, but well, yeah, right. Especially swimming. But anyway.
Yeah. Jumping on the train.
Right. Exactly. Okay. So real quick, kind of the four key things that you want that the AI needs. So you can give it a role. So like you saw, like when I did the Moxon antenna, I said, you are an expert radio engineer. When I do something for work, I say, you are an expert or a cybersecurity expert and also an experienced author, things like that. So if you give it a role, it kind of puts it into that mindset and sort of tells it what part of its model to focus on, if you will. So act as a whatever. Then give it context. Say, I am an amateur, I'm an extra amateur radio operator. I have this kind of radio, and I want to design an antenna for these frequencies. And then give it other constraints like, I have this much space to work with. I can't put up a tower, things like that. Just whatever, if you're talking to another person that's doing the work for you, you would need to tell them all that information. Then give it a task. Say, I want you to design the antenna, tell me the lengths of the wires, all that kind of stuff. If a matching transformer is going to be needed, tell me what kind of transformer and design it for me, that kind of thing. And then give it constraints, as I mentioned. So, like one of the constraints I often give it, like if I have it do some research for me in my work. And by the way, I never copy and paste because there are now AI detectors. So if I were to copy and paste something and give it to a client and they ran it through an AI detector and they realized the entire thing was generated by AI, they're probably going to say, what am I paying you for?
They say you have no defense. If the AI, they run it through a detector and say, hey, this is AI generated. Even if it's not, how do you prove it?
Right. Yeah, there's no way to prove it one way or the other. But anyway, the constraints I give it is that, like, I write these very short papers a lot of times, like 2 pages. And I'll say, okay, so I'm interested in this company. I can feed it all the data that I have on that company. I use a product called Google Notebook LM, which is for research. And then I'll say, generate a summary of, X, Y, and Z. Well, typically what I'll do is I'll generate like 4 pages worth of summary for each thing I ask for. What I really needed was a paragraph. Right. And so as a constraint, you can say, keep it short, no longer than a paragraph, or things like that. Right.
So there's your last line here, when you say it has context, is that because you're logged in and it recognizes your various sessions?
Like if you're using Claude, for example, and you're logged in with your account.
So if you want less context or no context, you create a different account or try to fake it out that you're
Yeah, or you can go and use the public web-based interface in incognito, right? Yeah. But yeah, in the context, like I found that the context with Claude Code, for example, if I'm working on a project, it's actually saving a file in the directory I'm working in that's got that context in there. So that when I come back to it later, it reads that file and says, oh yeah, okay, I know where we are. Right. So the same thing is happening if you're using the text-based interfaces.
Relatively new for some reason. Up until recently, get all your previous conversation.
Mm-hmm. Yeah, I think that's unique to Claude Code, because it has to store state information and stuff like that, right?
When you generated a website, how would that change over time? If you ask Claude like 2 weeks later, and it's like, oh yeah, I've got a new way, my code's gotten better in the last 2 weeks.
Yeah. Well, I have noticed, like, if I do that, so the question was, what if I go back 2 weeks later after I created the website and, and things are different now in Claude because it's got all these better ways of doing things. But I have noticed that what'll happen is when I ask it to do something, it actually goes through and it rescans all of the code because it doesn't know if something else has changed it, right? So it always starts over and rescans so it has a good understanding of what's there now. But yeah, anyway.
That's actually good to know.
Just like you're saying about how fast it's advancing, and if you use like GPT 3.4 versus 4 now, and whatever we're on, like every 2 months, it's like changing about what it can do. So if
Yeah.
you were asking the free version in February versus the paid version in April, it's way different. Or even going back to the free version now, which isn't as good as the paid version, it's eons have passed already in 3 or 4 months. Like,
Yeah.
wow.
Yeah, it's just changing so fast that it's hard to keep up. Well, and the other thing too, like when I go to work, I almost have too many tools. Like we have this internal tool that we created called Spark. And within Spark, I can pick from 6 different LLMs, everything from OpenAI to Claude to Gemini and sometimes like, well, which one should I use?
Yeah.
And the providers do give you some guidance. Like some of the models are fast, and so if you just need a quick answer to something, you can pick one of the lightweight models. And then there's deep research models, right, which take longer and therefore cost the company more, but they'll give you a more complete, more accurate answer, right? So it's just kind of trial and error a lot of times, just trying them out and figuring out, what works for you. And again, it's changing on a daily basis, it seems. So, yes.
Someone later tell us what for amateur radio, what software we should try and use to give the best answers for amateur radio stuff.
Yeah, so the question was, am I going to give you some advice on which tools to use? I can speak to my experience, so I will tell you what's worked for me, but obviously I can't spend all day looking at all this stuff from a ham radio perspective. But yeah, for me, if you haven't figured this already, I use Claude for everything. And for a couple of reasons. One is I don't trust OpenAI because they're very commercial and I don't know. There's a reason all those guys left OpenAI and started Anthropic, and it was safety more than anything. So, not to disparage, OpenAI, ChatGPT, which is a very good product, and you can probably get equivalent stuff. But if I'm going to put my money somewhere, I'm going to give it to Anthropic. Okay.
Notice the output on Claude is so much more elegant than the other models.
Yeah.
It uses italics for mathematics formulas. It's formatted in a very, very creative,
Yeah.
user-friendly way.
Yeah, you make a good point, Michael. And the point was that Claude seems to be like much more elegant, just in its speaking, whatever you want to call it. Its form, the formatting it uses, and part of that reason is that Anthropic, rather than put all of their money into generating pretty images, all they will do is they'll create an SVG image, and that is it. Right, whereas like Google Gemini, they've spent millions on Nano Banana so you can make cartoons and things. So Anthropic really invests their money more in the accuracy and the safety of the product than all these fun little consumer features, right? So I think it's a different mindset. The other kind of criticism of OpenAI is that they've gotten better, but like GPT-4, which was the model previous to this one, was very friendly and always wanted to be it didn't want to be very confrontational to the point where, there have been claims that it actually talked people into committing suicide by saying, yeah, I think you should just do that. Because it wanted to be friendly, it didn't want to argue with them. So, yeah, anyway. So, here's an example. There's a vague, help me with my antenna. Yeah. Okay. Or like you go to your doctor and say, doctor, I just don't feel right. Okay. And there's an example of a specific, that one's pretty obvious. Assigning a role. So here's just some examples. I'm not going to go through all these, but RF engineer, code generator, act as a Python developer. That's key if you're going to have it generate code and you want it to do it in a specific language. If you don't, it's just going to pick whatever it thinks is the best, which you may or may not have a license for generating C code or whatever it is, so that's useful. If you're working on getting your next ticket, if you're a tech and you want to become a general, you can tell it, you're an exam tutor of a general for this general license. Give me some random questions. And I actually have been thinking about this as a fun ham radio application, which would be to generate a video game to help people pass their exams, to make it more interesting. So my spare time, I'll work on that. And 3D design assistant. OpenSCAD is a free computer-aided design tool. And so you can tell it, you're an expert in this, generate a code for this, which you can then feed into a 3D printer. Or you probably don't even need to tell it that anymore. You can just tell it, what you need a case for this and this kind of printer, and it would do it too. Chain of thought. So this is where you get into the collaborative nature of these AIs. It used to be you would just tell it something and it would give you a response, and that was that. But now, because we have these context windows, you can actually collaborate with it or vibe with it. So example is with vibe coding. Like when I first started the club website, I just said, here's my club website. It was built in 2006. I hate it because it's ugly. It looks like 2006, but I want to keep I didn't say all that, but anyway, but I want you to keep all the content and, and translate that into a new website that has a modern look and feel, that will run without any external software requirements, using open source software on Linux. And it did an initial kind of a wireframe. It pulled in the content from the old website, and I just right out, shoot, it looked nice. But then there was all this stuff that I needed to fix, and I just would tell it, and that's vibing, right? So that's where I would go back and I would say, okay, next, I want to add a section. I want to move this here. The text is too dark, so brighten it up. I think Larry did you bring up the accessibility thing with color blindness?
Yeah.
Yeah. So he gave me a suggestion to make sure that it would work for people who are colorblind. And so I had it actually run it through tests, and it found the standards out on the internet and changed the fonts and stuff to make it, more friendly, all that kind of stuff. So this was just an iterative process, and it was like literally updating the website every time, and I would just go and look at it, and then I would go back and say, okay, that's great, but now let's do this. And so that's kind of the mode that you get into with these AIs. It's kind of fun. It's like literally working with an expert. And I'll put all these slides up on the website too, by the way. And as I said, the speaker notes have tons and tons of detail. So if there's something in there that you want more information for, and I know you're probably not too shocked about this, but I did use AI to help generate this deck.
Can you prove there's any of your own?
I can neither confirm nor deny that. So here's some quick tips. If you got actual data, that's kind of fun, right? So like you could connect your nano VNA and have it do a sweep of your antenna, and you can actually give it that sweep, the image of that sweep, and have it analyze it. Yes, sir.
Everybody's aware that the 60-meter regulations require a yearly analysis of your ERP.
Right.
And so I used one of the models to produce that analysis, and it was very accurate, really impressive.
Very cool. Yeah, Michael used an AI to help him generate the 60-meter ERP requirements. Cool. Yeah, so if you see something you're not uncertain about, you can ask it to do that. And again, the more data that you can provide it, like what I'm doing when I'm doing something for work, is I will find like, what happens is I brief with companies on their products. And so they'll send me 6 documents. They'll send me, a PDF of their standard pitch deck. They'll send me their financials. They'll send me all this stuff. And I drop all of that into the LLM, and then I can ask it questions, and it bases it entirely on that data. It doesn't go outside of that data, but you kind of have to tell it that. You say, do not reference stuff on the internet because you never know where that's coming from. It could come from Reddit, God only knows. So that's always helpful.
Is that right? Okay, next.
Yeah.
Yeah.
Well, it can be helpful if you're just like looking to solve a problem. The AIs will reference Reddit because there's a ton of a wealth of knowledge out there.
Tips and
Yeah, but you just sort of have to take it all with a grain of salt because they're humans, right? Yeah, using the model as a tutor. Yeah, that's a good way to learn things too. Say, explain to me whatever, right? Ask for multiple options, like give me 3 different designs. So tell it what you format. Do you want it in an image? Do you want it a WAV file? Do you want it a 3D printing document? Whatever it is, and it'll do that. And yeah, and start a new chat for new tasks. So we talked about the context window. If you go for a long time, they'll start to, complicate things. Like, for example, you just designed one antenna, now you want to start over with a new antenna design. You don't want to continue that chat because you want to start over with fresh context. So just start a new chat window. Excuse me. Okay, popular AI platforms. So Anthropic, again, we've talked a lot about that. Cloud Code is what I love to use for programming. I should say that, I mean, if anyone here has programming experience and you're familiar with whatever operating system you're going to be developing under, that's a huge plus. I have a friend who wants to bring up a website and he's not technical at all and he wants to use Cloud Code. And I'm like, well, I'm going to have to help you set up the environment to begin with, because you have to bring up a virtual machine running Linux. You have to install Claude on it. There's some steps to go through before you can start to actually do anything, right? And so that's where it gets a little tricky. Now you could ask Claude to help you with that, and I found that Claude is actually really useful because Linux is one of those things that I've used Unix for 30 years, but I can't remember all those command line, syntaxes and things. I just let Claude do it. And it's like, yeah, do this. And it goes out, figures out which command needs to be issued, and it does it for me. So anyway, so Anthropic's got Cloud Code, CoWork I talked about, and it's got the 3 different frontier models, Opus, Sonnet, and Haiku. And again, each one of those is targeted for different things. And I think I might have a slide that talks about what those do, but we'll see. Google's Gemini, I like Gemini quite a lot also. Especially as an interactive chat and for generating images. It's very accurate, it's very fast, and it makes really, really good images through Nano Banana. And also I use Notebook LM every day in my job.
Banana.
I don't know how they came up with that.
Banana.
I don't know. That's a good question. OpenAI, of course, that's what started the craze. The latest frontier model, at least as of yesterday or whatever, is 5.4. And they have their own code generator called Codex. And then Microsoft Copilot is really interesting. I use that also. We have access to that. It's connected to Excel and PowerPoint and all kinds of things. It also is connected to all of our SharePoint. We store everything in SharePoint at work. And so if I need to find a document, I can just ask Copilot to go find it for me rather than having to search for it, which is really cool. It will also reference the content in all of those files. So I could say something like, I just last briefed with, Microsoft 2 weeks ago. Can you go find that document? And it'll actually go out and get it for me.
Does it know every document in the database, or is he going out and looking for a specific document you requested?
It knows every document, excuse me, that I own or that's part of my SharePoint. And also we also have public, or not public, but common SharePoint repositories that have like all of our research data. So it's also indexed all of that.
It knows everything. It knows all your secrets.
Yeah, pretty much, which is why we run a private version of it.
Standard.
Yes.
Oh, okay, it's the same, it's just S.
Yeah. Yeah. S&P Global, Standard & Poor's. Yeah. Yeah, so it's pretty good. Ironically, Claude is better at doing things like Excel than Microsoft is. And it's just, I just find that really funny because Microsoft owns it, but they're a bit behind, I think, in terms of the complexity of their AI models and whatnot. Uh, Even though they own 49% of OpenAI or whatever, but
Yeah, exactly.
yeah, they're just not quite there. I don't know that they have any code generation offering yet. Yeah, I think they're just it's typical Microsoft though. They're kind of a little bit behind the curve. They wait and let these other companies make the mistakes first, and then, then they jump on. Okay, lastly, real world applications. I kind of touched on some of these. So practice Q&A is one thing you can do. Um, Concept drill down. I'm getting the reactants questions wrong, explaining these in terms of what's physically happening. If you got a weak area, have it focus on that, and help you create mnemonics. I never thought about that. That's kind of a cool idea. Antenna design, we probably beat that to death already. There's just all kinds of different things you could do. Yeah, you'll even create an input file for NEC2 that you can feed into it. Yeah, actually,
NEC2.
yeah, you could have it generate the file and feed it in. This is cool too. I actually had it generated or created an unplan for me. I said, I have a random wire antenna. I want to put 1,000 watts of RF into it. It has to be, weatherproof enclosure. So design the enclosure, tell me which ferrites I need, create a build list or parts list, and give me instructions on how to assemble it. And just like that, generate the STL file to create the 3D model for the cabinet or the case, the works. Oh, yeah, there we go, matching transformers. So there's a good example there. And again, I'm not going to read all these because these are just mainly for, to give you some ideas. Loss budget, that's kind of a fun one. Saturation check. What's that? Yeah. Which one? Probably most of the common models will do that for you. So you could go to ChatGPT, you could use Claude, whichever one you want to try. And since you can try all these for free, go for it. Just go out to each one of those and paste it in and see which one gives you the best answer. And that's kind of what I did. And that's how I settled on Claude for most things, because it just almost always comes back with the best answer. Mhm. Yeah, here, let me show you real quick. Let me copy this prompt and let's fire up the web browser. Or actually, I don't even do that. I can use the Claude app, but you can do that too. You can just go to Claude.ai, whatever. Okay, past the disclaimer, paste in what you need, send it.
The first thing you typed in was find Claude.
Oh, Claude.ai was the website.
Claude.ai, and got me to this window. And there you are.
He's using a web browser. So
Yeah,
it's
this
not
is the
even
web
there.
browser. Yeah. Claude.ai is the address to put in your web browser. What's that?
If you Google the word Claude, it comes.
Yeah, or Google the word Claude.
I bought the subscription. And I always forget this. If you're on the web, I put in that query and then it gives to me, and then I want to log in.
Mhm.
It deletes the query and then I start over. But the other thing is when I try to log in, it always looks like it wants me to sign up for an account. There's no login button. Am I missing something?
I don't know. That's a good question. Let's see here. Let's go back to Claude here.
I'm surprised you're
Getting the cardinal sin of computer programmers, that's having a tall drink next to your laptop.
Yeah, especially my brand new laptop.
Zach,
That, do it.
Well, I paid for Apple Care that includes accidental damage. Not that I want to wait to have this fixed, but you're right. Yeah, I don't want to have the coffee syndrome, the Pepsi syndrome going on. Anyway, yeah, so, oh, I'm actually already logged in. But if you log out, yeah, you just continue with email and you log in right here. So, yeah. Anyway, but I just use the desktop app most of the time, which is right down here.
yeah, phone. But, I've used my, phone number too many times since locked me out.
Oh, really?
For a while.
Interesting. But yeah, all right. Back to it here. But you saw how fast it came back with that response, the entire design in under a minute. All right, let's see. Okay, cool. 3D modeling, I kind of talked about this too. One of the biggest things I use my printer for is, and with AI, is just designing a box. It used to be you'd have to measure it out, and figure out how to go into an open CAD, or whatever. I use, what is it called? Tinkercad. But now you can just tell it exactly what you need, and the more explicit you are, the better, obviously. You can even do things like giving it a picture along with the dimensions, and it can model it based on the picture you give it. So crazy stuff. But yeah, everything from antenna clamps to portable gear to enclosures, you name it. A few more things, log analysis. I didn't think about this till it actually suggested that. But if you're doing a contest, you can actually have it parse your ADIF log and tell you who you talk to, what you need for your DXCC award, the most active bands and times, all kinds of things. You could combine that with whisper data, for example, and get a really cool propagation model. Gray line stuff even would be cool.
Waiting for CW decoding. So you can listen in your head and watch it on the screen.
Yeah, that's a good idea.
50 words per minute.
Yeah, that's the key, right? I'll bet it can do it, but yeah, propagation forecasting. So I should mention that I mentioned to a few of you guys, but one of the things that I've been working on is a station controller for my home station. I have a Flex 6400, and I built, again with Claude, I built a web-based dashboard which has on it the latest propagation, all the stuff that you would normally go to like QRZ for, the weather forecast. It has a radar image. I was going to bring it up, but I didn't have time to get through my firewall and everything before the club meeting. And also I built in a workflow engine, which will do, so I built a startup and a shutdown script. So I have everything plugged into Wi-Fi plugs, right? So I can bring it up where first it turns on the power supply. It waits 30 seconds. Then it switches a coax relay, which is also plugged in, or will be, I'm working on that, but it'll be plugged into a AC outlet, which flips the coax and activates the antenna. And the last thing it does is it hits another relay, which triggers the Flex's remote on-off port. And you can tell it to delay, so you have it wait, until all this is done. And then I have a shutdown, which is kind of the reverse of that. So I did that first, and Claude actually set it up so I could do drag and drop. I could add new things, it's all done through the web interface. Again, not a single line of code was written by me. And then the last thing I did is I had it use public weather APIs to pull back the lightning for the area. And basically, if it detects lightning within 10 miles of my station, regardless of what's going on, it shuts it down and disconnects the antenna. And I did all this within an evening, a couple hours. Yeah, it's crazy.
We need to talk.
Yeah, well, I know we were talking about the coax stuff. Yeah, I had the remote station in mind because I know how much crazy weather we get out there. So yeah, It's cool stuff. And it's all using free APIs. That's the crazy part too. Anyway.
What'd you run? You used Claude to produce this. And take us from there.
Yeah, so I have it running. This actually is running. I have a Raspberry Pi in my house, which is running Linux, right? I installed Claude Code onto the Pi.
Tell them the Pi, do things on its GPIO pins.
No,
Okay.
no. So the Pi is just hosting the web server and running the code, the station code. What the code does, which is all written in Python, is it reaches out through the internet to pull down the API data for the weather, right? And then, right. And then the workflow engine, what it's doing is I have a Casa, which is made by TP-Link, power strip, which has Wi-Fi in it, right? So it's a standard Wi-Fi power strip. It has like 8 different ports on it. I can control each one of the ports individually. And they're turned on and off just with a simple web request. It's an HTTP. What's that?
Simple relay contactors.
Yeah. Yep, they're just relays. Yep. And the cool and kind of scary, but the thing about the TP-Link is it doesn't require authentication. It's just a simple web request where you give it the IP address or the host name of the power strip and a command, like port 5 on, port 5 off. And I didn't have to learn any of that. The Claude figured all that out for me. All I had to do is tell it the IP address of the strip and it took it from there. Yeah. And so then you just build it into the workflow. And I wish I could show it to you, but it's got toggles, so I can control it manually on and off. And also I built in it a schedule. So like every morning at 2 a.m., in case I forgot to turn the station off, it automatically turns it off for me. All that. It was just
Kind of a sequel to Node-RED.
Yeah, right. Yeah, except for it's all running on my little Raspberry Pi and a single Python script. So yeah, and it's beautiful too. Anyway.
I downloaded Claude on my phone, told it to build me a ham radio CW decoder, and it's done. It's all.
There you go. All right.
Hold the phone up.
Let's see if it actually works.
Yeah, I was gonna say, but have you proved that it works?
Yeah.
I'm dying of curiosity to see it.
Yeah. Well, if it can detect, an Olivia digital stream, it didn't decode it necessarily, but it detected it that was recorded 20 years ago or whatever it was off of a speaker of somebody's radio. I bet it could probably do that. Mark, did you or Michael, somebody?
So logging into the remote, there's lots of steps. I gotta click on this part like a button, then I gotta click on the service, I gotta click on it. Yeah. And that with a stream deck.
A Stream Deck? Yeah.
So where it clicks the stream deck.
Out the window.
That's right.
Yeah, I bet you could do that because the thing about Flex, of course, is that's all open source kind of stuff, right? So you could probably point it at the documentation. Yeah.
Click on the radio right now.
Yeah, I did some preliminary playing around with the Flex. I had Claude ingest all the API documentation. And the next step is I'm going to start playing with it and have it actually replicate some of the controls. Because what's that? Yeah. Yeah, because it's all open, it's free. And so, yeah, Claude was just able to ingest all of that.
Yeah.
So, yeah, one of the things that I want to do is create a phone app that's like a miniature Flex, like a miniature Maestro without the waveform, the waterfall. But no reason. Oh, I actually told Lynn and Simon I was going to do it. They're like, go for it. Because it won't do anything like theirs do. I just want to be able to
Do that and expect a big offer from Flex.
Yeah. I don't know. With Claude Code, there's probably 10 other people doing the same thing right now. But anyway, I know Simon, Simon just made his Linux Smart SDR. He just published it out on the Flex website. And already there's somebody doing an open source version similar to his that's competitive. But, you know, Simon's looks exactly like Smart SDR though. I mean, it's like, it's really good.
Yeah, it's amazing how far it's gotten. Wow.
All right, so last but not least, using AI responsibly. This is probably some good advice for you. We already talked about hallucinations. Knowledge cutoff is an important one. So I talked about how they train the AI models. Well, there's a cutoff because they don't continually train because it's a very expensive, very time-consuming process to train these models. And so you can actually ask the model. You can say, "What is your knowledge cutoff?" And it will tell you when the training stopped. Now, it isn't that it doesn't know more because afterward they can add to it, but it's not as complete, right? So sometimes, the knowledge it's giving you is a year old or 6 months or whenever that model's training was cut off. Check the math. I have noticed this with any AI is that it's not necessarily that great at math. So sometimes you want to double check, especially if you're going to make a big project based on something it's designed, double check its math. It's also sometimes very bad at spelling, which is easier to spot. Yeah, no. Yeah, especially when you have it generate images for some reason. I don't know if this is on purpose, but a lot of times there'll be misspellings in the images and things. It's gotten a lot better recently, but
I think that'd be something that can nail.
right. Yeah, it doesn't have real-time data unless you specifically tell it you either paste that data into the prompt or you tell it where to find it. Because a lot of the AIs will not go to the internet unless you specifically tell them to do that. Yeah, verify specs, and definitely cross-check everything that it's doing. Okay, so your homework, if you haven't already, I know some of you guys have already installed it on your phones and are developing apps or whatever you're doing, but yeah, just give it a try. Just be careful a little bit. Make sure to double check, realize that the stuff it spits out isn't 100% accurate, especially if you're asking it for medical advice or whatever, you're going to jump off a roof and it tells you to do it, probably might want to think about that. But it's literally, I haven't been this excited about a new technology in 30 years, maybe 40. Since I first discovered basic programming in 1979, right? So this stuff is it's going to change the world. It's not something you can just bury your head in the sand because it's happening. And jump on and see what you can do with it. Yes, sir.
The ability to bring full data from different spots. How does this interleave with copyright and patent?
Oh my God.
Oh God, yeah. How much time do we have?
Yeah.
The question, Scotty, you want to talk about this one? How does it interleave with copyright?
Suing the jeepers out.
Yeah, well, yeah, because there've been documented cases like I mentioned, the Times is suing several of the model providers for using their copyrighted content, but at the same time, OpenAI signed a deal with Disney, allowing them to use all of their animated characters. So with some limitations, they're not going to create full-length features that they're limited to like 5-second videos or whatever, but. So some of that's self-correcting, where the providers, the model providers are realizing they have to license this content. So some of that's going to resolve, either through contractual or through regulations, right? Privacy is huge, right? I actually just wrote about this yesterday where we tracked down the amount of AI regulations or laws that were proposed versus passed last year in the US. I don't remember the exact numbers, but it was something like 300 were proposed across 50 states and 100 of them were enacted. So if you're somebody like an AI provider that's trying to keep compliant with all this, can you imagine what a nightmare that is? Because every state's got its own version of these things.
It's moving so fast too.
And it's moving fast. So you almost need AI to keep track of that too. But yeah, so I don't know. It's still a big question though. And privacy is a big concern of mine too. What's my data being used for? I don't know. All right. Well, on a positive note though, definitely give it a try. The free versions can do an incredible amount of stuff, and then once you get hooked, like the only thing I'm paying for now is a $20 a month Claude subscription so I can use code, and then it forces me to go to bed at, midnight every night when I run out of tokens. But anyway, yeah, it's cool stuff.
Recipes.
Oh yeah, recipes. Somebody was telling me that they took a picture of the stuff in their fridge and the AI told them what they could make with it. Right? I mean,
It says go to the store.
yeah, yeah. It's like,
You're no longer living.
by the way, did you notice that your milk is expired?
Yeah.
All right. Well, that's my story and I'm sticking to it. Thanks, guys.
Awesome.